In this lesson, we're going to look at solving absolute value inequalities. And the inequalities in these examples will look like this. So we're going to have the absolute value of some expression, some algebraic expression. It will be less than a number. Or you could see the absolute value of some expression will be less than or equal to a number. So you're going to have less than where you have an equal sign with it or without an equal sign. And then you have a greater than, so it could look like this. And you'll have examples where you're going to have the absolute value of some algebraic expression will be greater than or equal to some number. So we're going to look at examples of those types. Now, before we look at solving absolute value inequalities, let's recall what we mean by absolute value. So recall, absolute value is defined as distance from zero. So for example, if you recall this idea, if I have the absolute value of x is equal to, let's say, 4. The absolute value of x equal to 4. So remember what this means. This means that you're looking for a number whose distance is 4 units from 0. So if you look at this number line, there are two values of x for which the distance from 0 is 4 units. So we have a positive 4 and we have a negative 4. And so in previous lessons, when you solved absolute value equations, that was the idea. So you had a finite number of solutions. Remember that? So in almost all the examples we've done, we ended up with two solutions. So in this case, in this example here, our solutions would be these two numbers, 4 and negative 4, because 4 and negative 4 are 4 units from 0. Okay? So you would say x equal 4, and then x equal a negative 4. All right, but the point being here is several things. Absolute value is defined as the distance from 0, and in this particular case, we had a finite number of solutions. A finite number of solutions. Okay, so let's consider this absolute value inequality. So remember, this was an absolute value equation, which we've learned in previous lessons. This is an absolute value inequality. Now remember, in the absolute value equation, we had a finite number of solutions. In this case, there were two of them, positive 4 and negative 4. But consider this one. So you're looking at the absolute value of what number is less than 2. So I want you to recognize that in this particular case, if you look at this, there's an infinite number of solutions. An infinite number of solutions, right? So for example, if I look at this number line right here, so if I look at the number, let's say if I look at the number, let's say 1, the number 1, the absolute value of 1 is 1, right? And 1 is less than 2. So 1's a solution. But if I look at, let's say, 1.5, the absolute value of 1.5 is 1.5, and 1.5 is less than 2. Y'all agree? What about 0? So far, it looks like I have 3 solutions, but I want you to recognize there's actually an infinite number of solutions. So if you look at 0, the absolute value of 0 is 0, and 0 is less than 2. Negative 1, the absolute value of negative 1 is 1, and 1 is less than 2. If we look at, let's say, negative 3/4, right here, negative 3/4. Negative 3/4, the absolute value of negative 3/4 is 3/4, and 3/4 is less than 2. And you can look at any real number between negative 2 and positive 2, and all of those real numbers will be a solution. Now 3 is not a solution, right? So any number greater than 2 would not be a solution, because if you look at 3, the absolute value of 3 is 3, and 3 is not less than 2. But still, you have an infinite number of solutions because any real number, whether it's rational or irrational, between -2 and 2 will be a solution. But I want to talk about this in terms of this definition. Absolute value is defined as distance from 0. So I want you to think about the solutions to this inequality based on that definition, because it's going to help you when solving harder inequalities, more complex inequalities in a little while. So another way to think about the absolute value of x is less than 2 is this. So this means right here, this means, remember, absolute value is distance from 0. So the distance from 0 has to be less than 2. The distance from 0 has to be less than 2. So if I look at this number line right here, and so here's 0. So I want this distance to be less than 0. So do y'all agree that any number that I'm shading right here, any number that I'm shading, that distance from 0 is less than 2, because here's 2 right here. So it'll look like this. So I'm not going to go any further, because once I go further from 2, then that distance is greater than 0. I'm only looking in less than 0. And so I'm going to put a parentheses here, because remember when we dealt with inequalities, since there's no equal sign, you're going to use parentheses. So 2 is not going to be a solution to this absolute value inequality, because 2 is not less than 2. Okay, so 2 equals 2. So that's why you see a parentheses. And if I go on this side, less than 0, so notice this distance right here, see all that I'm shading? Those distances are less than 2, right? Less than 2. So 2 units from 0, less than 2 units from 0. In fact, I need to stop here as well. All right, so parentheses as well. Remember, no equal sign, so you can use parentheses. And so this looks like this. So we had an interpretation of this using the idea before, and now we're looking at the interpretation of this based on the distance from 0 is less than 2. All right, so the absolute value of x less than 2 means the distance from 0 has to be less than 2, and that's what you see here. All right. Now, when we rewrite this, I want you to notice how you're going to write this in terms of an inequality. So this is an interval right here. This is the graph, and notice I shaded it as an interval. And so when you look at this in terms of an inequality, this absolute value of x is less than 2 becomes this inequality. So remember, all of the solutions, all of the values of x must be between -2 and 2. So it looks like this. -2 is less than x is less than 2. So x must be less than 2, and at the same time, it must be greater than -2. So this and this mean the same thing. Okay, so that's the graph of the solution, and then that's the solution set written as an inequality. Okay, so this is inequality notation, so keep that in mind. So that's how inequality notation is going to look. Okay, and this is the graph. So I'm going to put that right here. This is the graph right here. Okay, so that was talking about absolute values less than 2. So let's look at greater than. Okay, so now consider the absolute value of x is greater than 2. So let's kind of guess at our solution. So I want you to recognize that you're going to have an infinite number of solutions here as well, because there's an infinite numbers of x whose distance is greater than 2. So for example, if you look at the number 7. So 7 is a solution because the absolute value of 7 is 7, and 7 is greater than 2, right? In fact, if I look at 3, 3 is a solution because the absolute value of 3 is 3, and 3 is greater than 2. If I look at, let's say, -8, -8 is a solution because the absolute value of -8 is 8, and 8 is greater than 2, and so on. So there's an infinite number of solutions. Now, I'm only plotting the points that are integers, but you do realize that there are some other real numbers that are solutions as well. So for example, 7 point, let's say 15. So 7.15 is a solution because the absolute value of 7.15 is 7.15, and 7 and 15 hundredths is greater than 2. But how does that look in terms of this graph? So keep in mind that you want to find all values of x such that when you take the absolute value of it is greater than 2, right? Another way to think about this is this, in terms of the definition of absolute value. So in terms of the definition of absolute value, what this means is the distance from 0 is greater than 2. So if you look at any number greater than 2, that distance, you see here, 0 right here. So any of these numbers here, that distance is greater than 2. Now, since there's no equal sign, I'm going to go ahead and use parentheses. So this is parentheses right here on 2. And then any number I'm shading is going to be greater. The distance from 0 will be greater than 2. So you see any number, that distance, see this distance is 2. So any number greater than that will be greater than 2. So see right here, that distance is 2, right? So any number greater than that will be, that distance will be greater than 2. So same thing here. So this distance is 2 right here. That distance is 2. So any number less than -2 will also have a distance that is greater than 2. So look at how this looks. So if you look at the graph, there are two intervals that you just graphed, right? In the previous one, when we looked at less than, absolute value less than, it was an interval. It was written as one interval. See that? Here, with absolute value greater than, you have these two intervals. The way you write this in terms of an inequality, remember with this less than, it was an inequality, this compound inequality. So this compound inequality. And the way you're going to write this will look different. So when you read this, see two inequalities, right? So you read this, let me write it like this. Absolute value of x greater than 2 becomes this. So you would say the solutions would be any real number less than -2, just like this, or any real number that's greater than 2, just like that. Okay? So you're going to write it as an or statement. So greater than would be an or statement. So remember the words I'm saying. So greater than, right? So greater than. So think of that greater. The way I'm pronouncing this is like an or, an or. So you see that or statement. All right. So here's how you're going to solve these inequalities. Okay, so if you have an algebraic expression, and remember you have to get the absolute value expression by itself, but if you have an algebraic expression, an absolute value algebraic expression that's less than some number, you're going to rewrite it like this. You're going to rewrite it as u is less than a, and at the same time, it has to be greater than -a. So it'll look like -a is less than u is less than a. So to see the a and its opposite. So you're always going to have its opposite there. If you have this one, absolute value of u is greater than a, you're going to rewrite it as an or statement. Rewrite as an or statement. So you can write it as u is going to be greater than a, or u will be less than its opposite, -a. All right. So be careful with this one. So think of it this way. See this part right here that I'm underlining with my finger right here? You're going to rewrite this without the absolute value bar. So you see without the absolute value bar, u is greater than a. But you're going to say an or statement. So remember greater, or, greater than. On the other one, you're going to do the opposite. So you're going to say u is less than the opposite, -a. Okay? All right, so don't try and memorize this without understanding all of this. So if you get stuck, as to how to rewrite each of these, think about these simple examples that we just did right here. So think about this as meaning the distance from 0. So the absolute value, you want that distance to be greater than 0. So that's those two inequalities. So you think of this or this, right? With this one, this distance is less than 0. So that's that compound inequality where you had all the solutions between -2 and 2. So that's x is less than, -2 is less than x, and x at the same time has to be less than 2. Okay? So think about think about what this means in terms of absolute value rather than memorizing this, because if all you do is memorize, at some point there's be so many things you'll be memorizing that you're not going to understand what to do when you get this situation, whether you do it like this or get confused some other way. All right? Okay. So let's look at some examples now. So now that you understand about absolute value inequalities and what they mean, let's look at some examples. Okay, so number 1, so you want to solve this absolute value inequality. Notice you have a less than. The absolute value expression is by itself, so that's good. Once I get to that point, once the absolute value expression is less than is by itself, look at your inequality symbol. That's a less than, right? So less than. So less than, that's that and statement. That's how you're going to write this as let me get to that page. You're going to write it like this. Okay? So basically, you're going to say the variable expression that's within the absolute value bars. You're going to say x minus 1 is going to be less than 4, and at the same time, x minus 1 has to be greater than a -4. So you're going to say -4 is less than x minus 1 is less than 4. Okay, so you're going to write it like this. Now the next thing you do, remember, the rest of this is from a previous lesson that you did. So you're going to get the variable x in the middle by itself, because you're trying to find what values of x will make this a true statement, will make that distance less than 4. Okay? So we're going to add 1 to all parts. All parts. There are 3 parts here. There's a left, middle, and a right. So add 1 to all parts. So -1 plus 1 is -3. Is less than x, is less than 5. And I found the solutions. So my solution to this original absolute value inequality would be any real number, whether it's rational or irrational, any real number between -3 and 5. So that's the solution in terms of an inequality. Okay? In terms of a graph, if you have to graph it by hand, then draw a number line, make sure you put 0, and let's say I need 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here is 5 right here. 1, 2, 3, 4, 5. So this is 5. And here's -3. 1, 2, 3. And I want to shading all solutions, all numbers between -3 and 5. Remember, there's no equal sign, so you're going to use parentheses. So on -3, you'll put parentheses. On 5, you're going to put parentheses. And you shade it in. Okay? Now, so that's the graph right here. So that's the graph of your solution set. And in terms of an interval notation, so remember how to write this from a previous lesson. You just look at the graph, or you can even look at the inequality. So you're going to say parentheses -3 comma 5 parentheses. Okay? Just make sure it looks like a parentheses and not a bracket, since there's no equal sign. All right, so that was pretty easy, right? That was pretty easy. And you can always check a couple. So for example, if you want to check to see if 4 is a solution, right? So let's see why 4 is a solution. What is 4 minus 1? 4 minus 1 is 3, right? And the absolute value of 3 is 3, and 3 is less than 4. Okay? All right. Now, let's look at number 2. Number 2, let's look at this example for number 2. Suppose we had the absolute value of x plus 3 is greater than 2. So this time it's a greater than. See that? Greater than. Again, make sure the absolute value expression is by itself, which it is. It's a greater. So greater means that or statement, right? So you're going to say x plus 3 is greater than 2, or x plus 3 is what? You do the opposite now. So you're going to say less than a negative 2. Less than a negative 2. Remember, see these opposites, right? See that 4? 4, negative 4. See this 2? 2, negative 2. But be careful because some students forget about switching this symbol right here. So with an or statement, you got to switch that symbol. Greater than, less than. Greater than, less than. Okay? All right, and then you solve each of those inequalities. So you can subtract 3 from both sides to get x is greater than negative 1. And then over here, you're going to get x is greater than negative 5. So when you graph this, and let me go ahead and use a number line without having to draw it. Okay, so the graph, now we're going to graph this. So notice this right here is the solution written as an inequality. So inequality. This will be the graph right here. So when I graph this, let's do this one first. So x is greater than negative 1, which is, I'm sorry, this should be less than, right? Okay, less than negative 5. So this will be less than negative 5. So x is greater than negative 1, which is right here. There's no equal sign, so I need parentheses. Okay, make sure you shade it in like this, and make sure you draw your arrow. Okay, so any number greater than negative 1 is a solution to this inequality. And any number less than negative 5, so here's negative 5 with parentheses, just like this, and you're going to the left. Okay, so those are your two solutions. Okay, I'm sorry, those are your solutions, the two intervals that represent your solution set. Now, as an interval notation, that one's easy. Interval notation. You make sure you go from left to right, though. Okay, so you're going to go from negative infinity to negative 5, negative infinity to negative 5, parentheses, union. Remember in a previous lesson when you dealt with two intervals, you put a union there. Union, and then from negative 1, parentheses, negative 1 to infinity. All right, and so that was number 2. Okay, so let's look at number 3. So number 3, we have this. Okay, so the absolute value of 3t minus 5 is greater than or equal to 1. So remember the absolute value expression is by itself, and it's a greater than or equal to, and I know there's an equal sign this time, so we're going to need those brackets, right? Okay, so you break it down to an or statement. So we have 3t minus 5 is greater than or equal to 1, or 3t minus 5, and you do the opposite. So greater than less than becomes less than equal to, and then 1 becomes negative 1. And then you solve each of those inequalities. So we're going to add 5 to both sides. So I get 3t is greater than or equal to 1 plus 5 is 6. Divide both sides by 3. 3 divided by 3 is 1. I get t is greater than or equal to 2. So any real number greater than or equal to 2 will make this inequality a true statement. Over here, if I add 5 to both sides, combine like terms, I get 3t is less than or equal to negative 1 plus 5 is 4. Divide both sides by 3. I get t is less than or equal to 4/3. So any number less than or equal to 4/3 is a solution to this inequality as well. So in terms of inequality notation, this would be your solution, written as an inequality. Okay. In terms of a graph, this is what it's going to look like. Okay, so the graph's going to look like this. So we're going to do this one first. So I'm looking for all the values of x that are greater than or equal to 2. So here's 2. Remember, you see an equal sign, so you're going to put bracket, just like this. Make sure it looks like a bracket, okay? Make sure it looks like a bracket, and you're going to shade in every real number that's greater than 2, just like that. Make sure you put your arrow. Over here, now make sure you estimate where 4/3 is. So 4 1/3, remember, is 1 1/3. So here's 1. So let's say 1 1/3 is about here. So see the equal sign? So we need a bracket, just like this, about like this. And then you're going to shade in all numbers that are less than that. Okay, don't forget to put your arrow. All right, and then, so there's the graph. So this is your graph right here. Then interval notation, you're going to say, so you have two intervals. So make sure you write two intervals. So you're going from negative infinity all the way to 4/3. So negative infinity, parentheses. Remember, with infinity, negative infinity, you always use parentheses. Negative infinity to 4/3 with the bracket because of the equal sign. 4/3 is a solution. And make sure you understand why from a previous lesson, 4/3. So think about that. 3 times 4/3 is 4. 4 minus 5 is a -1. The absolute value of -1 is a +1, and 1 is greater than or equal to 1 because it's equal to 1. Okay? Union. And then on this one, that will be 2 to infinity. 2 to infinity. So 2 with a bracket, infinity with parentheses. So that's number 3. So very simple process, right? Looks very simple. Okay, so let's look at number 4. So number 4, we have an absolute value. The absolute value expression is by itself. It's a less than equal to. So that's that compound inequality that we wrote it as. So we're going to say -1 is less than equal to 6 minus 5y is less than equal to 1. Okay? And then we got to get that variable y in the middle by itself. So I'm going to go ahead and subtract 6 from all parts. -1 and a -6 is a -7. It's less than equal to a -5y. It's less than equal to 1 and a -6 is -5. Okay, now be careful with the next step because notice I'm trying to get y by itself. So I'm going to have to divide both sides by all parts by -5. Okay, but remember, and this is important, I'm going to write this over again. Remember, when you divide both sides of an inequality by negative number, you have to reverse the inequality symbol. Okay, so at this point, I'm going to divide all parts by -5. All parts by -5. You saw that in a previous lesson. When you divide all parts by a negative number or multiply by a negative number, you're going to have to reverse these inequality symbols. So -7 divided by -5 is a +7/5. It's going to be greater than or equal to y. -5 divided by -5 is 1. And that's going to be greater than or equal to, and the -5 divided by -5 is a +1. Okay? Now remember, we tend to write this kind of statement going from smallest to largest. So right now, 7/5, is greater than 1. So let's go ahead and rewrite this backwards. So I get 1. Remember, this right here means the same thing as this. 1 is less than or equal to y, which is less than or equal to 7/5. Okay? So here's your inequality notation. So there's your solution in terms of inequality. So any real number between 1 and 7/5 is a solution to this inequality, to this absolute value inequality. Okay, so let's look at the graph. So the graph will be this. Okay, if you draw it by hand, make sure you show 0. So let's say this is 0. And all these are positive numbers. So I'm just going to put -1, although I don't need it. Here's 1. Remember, 7/5. 7/5, remember, is 1 and 2/5. So here's 1, and here's 2. So that's really all I need, right? So I'm going to so I need to shade in all the solutions between 1 and 7/5. So notice the equal sign. So I'm going to need brackets. So here's 1. And then 7/5 is 1 and 2/5. So let's say that is about here. So 2/5 is 0.4, so that's less than 0.5. So it's a very it's going to be hard for you to kind of graph this because here's 1.5 right here. So let's say this right here is 7/5 right here. So here's the graph. Yeah, so this graph was a little bit more challenging, wasn't it, to graph, because the solutions are between 1 and 2/5. Okay, so there's the graph. It's a little bit challenging for the graph. The interval notation, you're going to say bracket 1 all the way to 7/5 with the bracket, right? Okay, so that was number 4. So let's do number 5. Number 5. Okay, so when doing number 5, remember you need to get the absolute value expression by itself, and in this case it's not. So we have to notice the absolute value expression is being multiplied by -2, and you're also adding 7 to this expression here, to this term. So let's go ahead and subtract 7 first. So we're going to subtract 7 from both sides, just like this. So I get -2 times the absolute value of 3x plus 5 is less than or equal to, and the -13 and -7 is a -20. Okay? Now remember, this is not parentheses, so don't distribute. Do not distribute this. You're going to get a major error. Do not distribute. This is not parentheses. That's absolute value expression. Okay? All right. So you saw that when we talked about absolute value equations. So remember, we discussed this absolute value equation. So these are not parentheses, so don't distribute. The next thing you have to do is, and I'm going to go ahead and rewrite this over. The next thing you have to do is to divide both sides by -2. Now remember we talked about in previous lessons with inequalities was that when you multiply or divide both sides of an inequality by a negative number, which I am, you have to reverse that inequality symbol. So -2 divided by -2 is 1. 1 times the absolute value of 3x plus 5 is the absolute value of 3x plus 5 is going to be greater than or equal to -20 divided by -2 is 10, right? Okay, so that's what I have. So now I have the absolute value expression by itself. It's a greater than, so there's your OR statement. So 3x plus 5 is greater than or equal to 10, or 3x plus 5 is less than or equal to -10. Okay? And then let's solve each of those inequalities. So I'm going to subtract 5 from both sides. So I get 3x is going to be greater than or equal to 5. Divide both sides by 3. I get x is greater than or equal to 5/3. So any real number greater than or equal to 5/3 will be a solution to this original absolute value inequality. Over here, subtract 5 from both sides. I get 3x is less than or equal to -15. Divide both sides by 3. I get x is less than or equal to -5. So this right here, don't forget to put the OR statement. This right here would be your solution written as an inequality. Okay. Now let's go ahead and graph it. So let's look at the graph. All right, so as a graph, let's graph this in first. So remember 5/3 is 1 1/3. So we're going to approximate where that is. So I want to shade in every real number that's greater than or equal to 1 and 2/3. So 1 2/3, let's say, is about here. So bracket, just like this. Make sure it looks like a bracket. And you shade in every real number greater than that. And then x is less than or equal to -5. So here's -5 right here. So on -5, draw a bracket going to the left. And there's your graph. Okay? So you have an infinite number of solutions. You have solutions here, solutions here. In interval notation, and make sure you always go from smallest to largest. So let's start with this one. So you're going from negative infinity to negative 5, parentheses, negative infinity, 5 with a bracket, union, and then bracket 5/3 to infinity with parentheses. Okay, so that was number 5. So it's a very simple process, isn't it? It's not difficult at all. Very simple. Okay, let's look at number 6. Okay, so in this example, a lot of students get confused with this one because the absolute value expression's on the right-hand side. Well, if that confuses you, then go ahead and write on the left-hand side, which is what I would do. So I would reverse the inequality here. So I would say, just write it backwards. So this right here means the same thing as this. Means the same thing as saying the absolute value of 5 minus 2x. So remember when you read this, you read it as 7 is less than the absolute value of 5 minus 2x, or you can say the absolute value of 5 minus 2x is greater than 7. So these two mean the same thing, okay? And then let's look at this analysis. See, very simple. So this is greater than, so that's that or statement, right? No equal signs, everything's going to be parentheses. So you can say 5 minus 2x is greater than 7, or 5 minus 2x is less than negative 7. Okay? And then you just solve the each of those linear inequalities. So we're going to subtract 5 from both sides. So 5 minus 5 is 0. 0 to negative 2x is a negative 2x. It's going to be greater than 7 minus 5 is 2. All right, now be careful with the next step, right? So let me go ahead and rewrite this over to remind you. To get x by itself, I'm going to have to divide both sides by negative 2. So remember, when you divide or multiply both sides of the inequality by a negative number, which I am here, you have to reverse the inequality symbol. So negative 2 divided by negative 2 is 1. 1 times x is x. It's going to be less than negative 1. Over here, subtract 5 from both sides. 5 minus 5 is 0. So 0 to negative 2x is a negative 2x. It's going to be less than. Negative 7 and a negative 5 is a negative 12. Okay, I'm going to rewrite this over. Remember, to get x by itself, you got to divide both sides by negative 2. Same thing here. When you divide or multiply both sides of an inequality by a negative number, you have to reverse the inequality symbol. So negative 2 divided by negative 2 is 1. 1 times x is x. Is going to be greater than negative 12 divided by negative 2 is 6. So your solutions to this absolute value inequality will be any real number that's less than negative 1 or any real number that's greater than 6. And so there's your solution as an inequality. Let's go ahead and graph this. So when you graph this, we're going to get this. Okay, so the graph, let's do this one first. So x is less than negative 1. So notice there's no equal sign, so it's going to be parentheses. Here's negative 1 right here. So you want to shade in all the real numbers that are less than that. So parentheses and negative 1, make sure it looks like parentheses. And then any real number less than negative 1. Make sure you draw your arrow to indicate that it continues to the left side. Continues to negative infinity. And then greater than 6, so here's 6, parentheses on 6. Make sure it looks like parentheses. Make sure it looks like parentheses. Erase it if it doesn't look like it. And then shade in every real number greater than that. So you have your two intervals. And now you're going to write it in interval notation. Always go from smallest to largest. So you go from negative infinity to negative 1 with parentheses. Negative infinity to negative 1, union, and then parentheses 6 to infinity. All right, so again, very easy. Number 6. Let's look at number 7. Okay, so number 7, we have this absolute value inequality. So remember, you need to get the absolute value expression by itself. So I need to get rid of this 2 and this 3. So right now, always get rid of the multiplication at the end. So let's get rid of the addition first. We're going to subtract 2 from both sides. And so I get 3 times the absolute value of x minus 1 is greater than or equal to 6. And then I'm going to go ahead now and divide both sides by 3, just like this. Notice I'm dividing by positive numbers, so it stays greater than or equal to. I don't switch the inequality symbol. 3 divided by 3 is 1. 1 times the absolute value of x minus 1 is the absolute value of x minus 1 is greater than or equal to 2. Now at this point, you're going to rewrite it without absolute value bars. So this is a greater than, so that's that or statement. So x minus 1 is greater than or equal to 2, or x minus 1 is less than or equal to negative 2. And then you solve each of those linear inequalities. So I'm going to add 1 to both sides. So I get x is greater than or equal to 3, or, and over here, add 1 to both sides. I get x is less than or equal to negative 1. So any real number greater than or equal to 3, or any real number less than or equal to negative 1 will be a solution to the original inequality. So there's your solution in terms of inequality. Okay, if you look at it in terms of graph, I'm going to go ahead and just draw it. So when you do it by hand, here's 0, let's say, 3, 1, 2, 3. And then I want to shade in every real number greater than or equal to 3. So there's that bracket on 3. Here's 3. And then shade it in and draw your arrow. Make sure you draw your arrow. Negative 1 is here, to the left, bracket to the left, and shade in every real number to the left. Okay? All right, so that's the graph right here. This is the graph. Then in interval notation, go from left to right. So negative infinity to negative 1 with the bracket, union, and then bracket 3 to infinity. Remember, parentheses around infinity, negative infinity. So that's number 7. So not difficult at all, right? Very simple process. Okay, so number 8, we have 3 minus 2 times the absolute value of x plus 4 is greater than 5. So before you rewrite without absolute value bars, remember you got to get that absolute value expression by itself. So let's go ahead and always do the multiplication last. So let's go ahead and subtract 3 from both sides. I'm going to subtract 3 from both sides, combine like terms. 3 minus 3 is 0. 0 and a negative 2 times the absolute value of x plus 4 is a negative 2 times the absolute value of x plus 4 is greater than, and then 5 and a negative 3 is 2. Now remember from previous lessons, this is absolute value, not parentheses, so don't distribute. Do not distribute. You're going to make a major error. So when you have absolute value expression and you have a negative coefficient out here, you need to divide. So at this point, go ahead and rewrite this over. At this point, I'm going to divide both sides by a negative 2. Now remember, I divided by negative 2, right? Divided an inequality by a negative number. So I have to reverse an inequality symbol. So 2 divided by negative 2 is 1. 1 times the absolute value of x plus 4 is the absolute value of x plus 4 is less than. And then 2 divided by negative 2 is a negative 1. Okay, so that's where I'm at. All right, now, so we're at this point, and we got to discuss this right here because we really didn't talk about something like this yet. So I want you to notice something. I want you to think about this. So notice that I have the absolute value expression here, and think about what absolute value is. So remember, the absolute value is the, think about distance. You want this distance right here to be, this says negative 1 units from 0, right? Well, that's not possible because distance is positive, correct? Distance is positive. So see how you have the absolute value of x plus 4 is less than negative 1? Remember, the absolute value of whatever that number is here, the absolute value is going to be 0 or positive. It's never going to be less than a negative number, correct? So a positive number is never less than a negative number. So right now you can say this is no solution, no solution, no solution, okay? Because the absolute value, remember the absolute value is always positive or 0. It is never going to be less than a negative number. Okay, so that was something new. I didn't expect to get to this one, but that's fine. We need to know that anyway. So you say no solution. So whenever you get the absolute value expression by itself, If you go back to all the ones we've done, I want you to notice when we went to everyone we've done, that number, when we got the absolute value bars by itself, that number on the other side was always positive. We just so happen to get one that's negative, so that's no solution. Okay? All right, so let's go to number 9. Number 9, I'm going to redo the same problem, but this time I'm going to make sure this is positive. So let's say we had this for number 9. We had 3 minus 2 times the absolute value of x plus 4 is, let's say, greater than negative 5. Okay? So this one was 5. This one's negative 5. Let's see what happens. Okay, so I'm going to subtract 3 from both sides. And this is 0, so I get negative 2 times the absolute value of x plus 4 is greater than negative 8, right? Okay, and then we're going to divide both sides by negative 2, just like this. And when I divide both sides by negative 2, remember you got to reverse that inequality symbol, correct? So when I reverse that inequality symbol, negative 2 divided by 2 is 1. 1 times the absolute value of x plus 4 is the absolute value of x plus 4 is going to be less than negative 8 divided by negative 2 is a positive 4. Okay, now I'm going to get solutions here, right? So I will get solutions because the absolute value here can be positive or 0, and a positive number or 0 can be less than 4. Okay, well, some positive numbers can be less than 4, but I'm going to get solutions because this number is positive. Okay, so let's go ahead and remember that's a less than, so that's that compound statement. So you're going to say negative 4 is less than x plus 4 is less than 4, right? So let's subtract 4 from all parts, and you get negative 4, and a negative 4 is a negative 8 is less than x. This is 0, and that's less than 0. So your solutions to this original inequality, absolute value inequality, would be any number between negative 8 and 0. So there's your inequality. In terms of a graph, so here's 0, negative 1, 2, 3, 4, 5, 6, 7, 8. So you're going to say parentheses negative 8, parentheses 0, just like this. And you're going to shade in every real number between those two. Okay? All right. So just be aware about number 8 again. Just remember the absolute value, you're going to get solutions. You're not going to get solutions here because the absolute value must, when you take the absolute value of this expression, it's going to be positive, and a positive number is not less than a negative 1, or you can get 0, and 0 is not less than a negative 1. Here you're going to get solutions because if this is a positive number, there are positive numbers that's less than 4, right? And if this is 0, 0 is less than 4. All right, so that's why you get solutions here, and you don't get a solution here. All right, and the same thing was true for the others. So if you notice, if you go back here, and you got to this point here, when you got the absolute value by itself, you are going to get solutions because the absolute value of a number can be positive, and there are positive numbers that are greater than or equal to 2. It could be 0, right? It could be 0, and 0 is not greater than or equal to 2, but that's okay because there are positive numbers that are greater than 2. So that's why you see solutions here. If you go to number 6, let's talk about one more. Go to number 6, same thing here. You're going to get solutions. You're going to get solutions because there are positive numbers that are greater than 7. If you go to, let's say, this one here, this right here, you're going to get solutions, and we did, right? You can get solutions because there are positive numbers. There are positive numbers that are less than 1, right? And 0 in this case, because 0 is less than 1. Okay, so just think about things like that. Always think about, will I end up with solutions or not? And you just look at, when you get that absolute value expression by itself, look at what's on the other side. And think about what you have here. The absolute value of that expression to be positive or 0. Positive or 0 is never less than a negative 1. Okay? All right, let's look at one more, one or two more, because I want to try and do enough examples to get you through some of these problems you're going to be dealing with. So let's go to number 10. So number 10, let's suppose we had this. 2 minus 3x divided by 5 is greater than or equal to 2/5. First of all, I want you to add, I want you to think, am I going to end up with solutions here? And the answer is yes, because this is either positive 0, and I do have positive numbers that are greater than or equal to 2/5, right? 3, 7, 7.6, right? Okay, so I'm going to get solutions. So that means I can rewrite this into greater than, into an OR statement. So 2 minus 3x divided by 5 is greater than or equal to 2/5, or 2 minus 3x divided by 5 is less than or equal to a negative 2/5. All right, so let's go ahead and I'm going to go ahead and see the LCD is 5 here and 5 here. So I'm going to multiply both sides by 5 to go ahead and clear the fractions. So I'm going to rewrite this over. So I multiply both sides by 5 to clear the fractions. So 5's divide out, 5's divide out, and I have 2 minus 3x is greater than or equal to 2. Subtracting 2 from both sides, 2 minus 2 is 0. 0 to negative 3x is a negative 3x is greater than or equal to 2, and a negative 2 is 0. All right, now to get to the next point, be careful, because if you notice what you have, you're going to have to divide both sides by negative 3. When you divide an inequality by a negative number, or multiply an inequality by a negative number, you have to reverse an inequality symbol. So negative 3 divided by negative 3 is 1. 1 times x is x. Is going to be less than or equal to, and then 0 divided by negative 3 is 0. Over here, so what I have here is that any real number less than 0 is going to be a solution to this. Okay, now doing this one, so we're going to rewrite this over. So again, I'm going to clear the fractions. And when I clear the fractions, I multiply both sides by 5, which is the LCD. The 5's divide out on both sides. 2 minus 3x is less than or equal to a negative 2. Subtracting 2 from both sides. 2 minus 2 is 0. 0 to negative 3x is negative 3x is less than or equal to a negative 2 to negative 2 is negative 4. Okay, at this point, I need to divide both sides by negative 3. When you divide an inequality by a negative number, both sides of an inequality by a negative number, you have to reverse the inequality symbol. So 1, negative 3 divided by negative 3 is 1. 1 times x is x. Is going to be greater than or equal to a negative divided by negative is a positive. So you get positive 4/3. All right, and so there is your solution in terms of an inequality. So any real number less than or equal to 0, or any real number greater than or equal to 4/3 will make this inequality a true statement. In terms of the graph, if you do it by hand, remember 4/3 is 1 1/3. So if this is 0, this is 1, this is 2. So let's do this one first. So x is less than or equal to 0, bracket, because of the equal sign, going to the left. Shading like that. Make sure you draw your arrow. Over here, 4 1/3 is 1 1/3. So let's say that's about here. And bracket going to the right. Just like this. Okay? And so your interval notation, make sure you always go from smallest to largest when you're dealing with interval notation. So you go from negative infinity to 0, parentheses, negative infinity to 0 with a bracket, union, and then bracket 4/3 to infinity. Now, if you want to rewrite this as a fraction, you can. So you could have said negative infinity to 0, union, bracket, 1 1/3 to infinity. But don't write as a decimal, because this decimal does not terminate. So leave it as a fraction, just like we have. All right, so that's number 10. And let's look at one more. So let's look at number 11. Number 11. And that will be it. After we do number 11, I think you have enough examples to get you through the problems you'll see. So in 11, I have the absolute value of 2x plus 3 is less than 7. A lot of students get confused with this because all they see is a monomial here, 2x. But it's a lot easier than the others. So if you subtract 3 from both sides, I get the absolute value of 2x is less than 4, right? Now ask yourself, am I going to get solutions here? The answer is yes. Because the absolute value here, whatever x is, the absolute value is going to be positive or 0, and you do have numbers that are and you do have positive numbers that are less than 4, and actually 0 is less than 4 as well. So you are going to get solutions. But this is a less than, right? So you're gonna write that compound statement. So you're going to say negative 4 is less than 2x is less than 4. And then we're going to divide both sides by 2. So I get negative 2 is less than x is less than 2. And there's your solutions as an inequality. So any real number between negative 2 and 2 will make this original problem a true statement. In terms of the graph, here's 0, here's negative 2, here's 2. So there are no equal signs, so it's all going to be parentheses. So parentheses, parentheses, shade in every number between negative 2 and 2. And in terms of an interval notation, you're going to say parentheses negative 2, comma, 2 parentheses. And that's it. Okay? So that is the lesson on solving absolute value inequalities. Let me go back to that original statement. Okay, so in this lesson we looked at about 11 problems on solving absolute value inequalities. Now, before you memorize, and I mentioned this earlier, before you memorize this right here, make sure you understand. Don't just memorize this right here. Make sure you understand why when you have this absolute value less than, you write it like this, and why when you have absolute value greater than, you write as an or statement. Make sure you understand that, and that understanding came from these examples right here. Okay? All right, so that will be the end of this lesson.